started. Okay. All right. Hi, everybody. Welcome to Event Driven Computing. Now, if you're wondering what you needed to do ahead of time, if you needed to do anything ahead of time to get ready for this lecture session, nope, that's fine. That's it. Being a first thing Monday morning kind of lecture, I know that uh, that doesn't necessarily leave a lot of time to prepare beforehand in terms of the rest of the week. So what we're going to kind of do is effectively treat the Monday morning lecture as looking at the stuff from the previous week's worth of readings. So that's what the go there is going to be. Let's take a look at brief course admin. So for the time being, I just wanted everybody to have a review of all the key course admin information, but we're just going to go over that again in a bit more detail now, just so that we're all on the same page there. So hello, I'm Ian, I'm your course coordinator. I've taught event-driven computing in some capacity for about the last 5 years or so, something like that, possibly a little bit longer. Contact me for any sort of if you have any issues around the course, any specific questions regarding course admin, assessment, grading, contact me. Please message me on my uni. If you contact me through email or other channels, your email may get lost in the absolute mass of emails that I receive on a regular basis. So please contact me on my uni. I can keep track of all requests sent via my uni, even if I don't respond immediately. But generally, I'll try to respond fairly quickly to you if you do contact me via my uni, if you need to contact me. We do have a couple of course tutors, and you'll get to meet them in workshops in week 3. So what is event-driven computing? What is this course about? We'll come back to specifically what is event-driven computing and how we can do different bits and pieces with that in a little bit. But in general, what is this course about? Well, this course is about event-driven architecture. So how do we develop software for event-driven systems? How can we model those systems? How can we develop different types of models for organizing and managing software and event-driven systems? Understanding a little bit about how the computer itself handles events and the concept of events, how we use events, and how those events are implemented in different programming languages, and some common use cases for events in programming, which is, for example, graphic user interfaces and a few other bits and pieces, network interfaces, those sorts of things. We're also going to move into some more modern approaches to event-driven computing. We're going to look at functional reactive programming at a fairly high level, and we're also going to look at event stream and event stream management. This is where we start to look at the idea of events rather than being discrete, separate things that occur. We look at them in the context of other events, and we look at them as a stream of things that we can action or modify based on their properties. And we can then look at taking multiple sources of events and combining them together and manipulating those sources of events. So there's a whole lot there. For those of you who might be rejoining us from last year, there's a few different bits and pieces that are changing in that section. I'll keep you updated on that. And finally, I'm going to have a big emphasis on testing this year. We run into a whole lot of different interesting issues when we start programming for an event-driven system. Traditionally, the kinds of programming that you've probably been doing in your degrees up until now may not have been event-driven. You might have been writing standard procedural code that, waits for a user to do something. Maybe user does it, then it just goes away, churns, does a bunch of stuff, and once it's finished doing all of that different stuff, it's going to go ahead and then come back and it's going to spit out a result of some sort, and then the program is done. Whereas in this case, we're looking at all of the different things that can happen with a system that can receive inputs and events at any given time. So event-driven code is particularly susceptible to errors, and that's going to be quite challenging, and that always is quite challenging. So there's going to be a focus on making sure that we have actually properly tested our code. Yeah, so that's what this course is about. How's it going to be structured? We have classes. We are going to have a lecture slot, this lecture slot on a Monday. And while I'm talking at you a bit for this particular very first introductory lecture, for the most part, we're going to focus on examples and discussion. And that means that I'm going to be expecting that everybody has actually read the appropriate course notes and chapters in books when they get here, and that you have done at least some amount of preparation beforehand. So for each week's module, you'll see that there is a section labeled before lecture. Make sure you go through and you do all of the stuff in the before lecture section before actually coming to this session on Monday. We're going to focus on, again, examples and discussion rather than me actually delivering content. As you can expect with all of your classes, these sessions will be recorded, but because this is an example and discussion kind of session, you will get most out of this session by actually being here live. So it's my recommendation that you do actually make the time to be here live if you can. We also have workshops. Workshops start in week 3. And they are sort of going to be a bit of a hybrid between a regular workshop or a regular tutorial and a Q&A session. So we will have some exercises for you to work through during workshops if you want, but they are a good time to ask questions, work on programming assignments and get help with programming assignments, and we'll split up the time a little bit to accommodate that. So that is the plan. Okay. We're using Piazza for our class discussion board. Hopefully some of you, or hopefully most, if not all of you, have used Piazza before. Piazza has a bunch of different nice features that make it really nice to use. You'll find Piazza linked on the left side of my uni. So if you're going to ask just a general question or a question about a specific topic, hop on over to Piazza. You'll find the link on the left side of my uni instead of discussions. A few good things about Piazza: you can go ahead and you can create questions, and it supports all the usual stuff that you'll find in your regular discussions. In addition, it also supports Markdown as well as plain text, which is nice. And then once you have a question up and running, everybody can collaborate on one answer together. So I just create a topic here. And I don't think I can create, no, I can create questions. So you can choose whether it's something that you want an answer to or not, or whether it's just a general comment. You'll need to select a topic or folder, and there will be topics and folders for everything. And then once the question is up, there'll be a section for you to write an answer in if you want. And once an answer has been written, other students can go in and also edit and add to that answer. And that's really what makes this tool very powerful. In addition, we can do things like grouping similar questions together, and a bunch of other bits and pieces. We'll be using Piazza a little bit later in this session for going through some discussions. And we'll probably be using Piazza for live discussion throughout lectures as well throughout the rest of the semester. Okay, now a couple quick notes for when you're using Piazza. Check to see if questions exist. Piazza does contain a tool to help to see, make suggestions about questions. If you're asking a question, it might say, oh, I think this might be similar to this other question. Check to see if a question already exists. There's not that many of us in this course this semester, this time around. So hopefully that means that we aren't just getting an absolute flood of questions, which does happen in some of the larger courses. And that means that hopefully it should be fairly easy for you to see if a question already exists or not. But one of the nice things about Piazza is that you can click on each of these topics up here. So if your topic was about DFAs, for instance, if you click on DFAs, it's going to filter out just the questions about DFAs. And similarly, all these other topics, you can filter by those. So it should be fairly easy to take a quick look and see, does this question already exist? And if it does already exist, take a look, maybe add to the question if you're unsure. Please avoid posting large or complete sections of code, even if the code doesn't entirely work. Try to keep your snippets fairly small. Otherwise, we can potentially run into some academic integrity issues with other students just grabbing your code and plonking it into their own work. That shouldn't be a huge issue for this course, but it does happen. So avoid posting large and complete sections of code or complete sections of code. One of the nice things about Piazza is that it does allow you to post anonymously, and I am a big advocate of making sure that everyone has the opportunity to post completely anonymously. There's a couple caveats with that. If you actually want help with something, when you post anonymously, there are two options. You can either be anonymous to everyone, myself included, or you can be anonymous just to your classmates. And if you go anonymous just to your classmates, then I can see who you are. The other instructors can see who you are, but the rest of the class can't see who you are. So if you are feeling a little bit unsure about a question and you don't want the rest of the class to see who you are when you're asking, that's a good option. Or you can go completely anonymous when asking a question. And I think having that option for people does tend to foster open discussion a bit, but it kind of goes both ways. So first of all, if you want help from the teaching team, I can't help you if I don't know who you are. So please don't use anonymous to everyone if you actually want one of us to be able to check your work or to be able to check your settings and help you. Similarly, when posting anonymously, bear in mind to be polite and civil in the same way that you would if you were posting with your name attached to it. We can still ban users even if they post anonymously. We won't know who we've actually banned, but I can ban you from Piazza for some amount of time if people get nasty with each other. So please, I know that I believe that having you able to post anonymously fosters open discussion. Please don't abuse that. Yeah. All right. Basic assessment structure of this course: 3 programming assignments, each worth 20%, and then an exam worth 40%. The exam does have a hurdle requirement on it, which means that within the exam itself, you will need to score 40% at least to be able to pass the course. It doesn't mean that you will pass the course if you score 40% on the exam. It means that if you were to, for example, smash out all of the programming assignments and get full marks on all of those so that your grade was at 60% overall, you would then still need to get at least 40% on the exam to be able to pass the course, even though your overall course grade would be above 50 otherwise. So it does have a hurdle. If that's the case for you, that particular scenario, you would be offered a sup or replacement exam. And anyone whose grade falls in the 45 to 49 range is going to automatically get a chance to take the sup exam. In terms of the exam structure and content, there'll be a few more details on that closer to the assessment date. Just to emphasize the hurdle requirement there. So again, even if you smash out the programming assignments, you still need to get at least 40% on the exam, and it should not be tremendously difficult to get 40% on the exam if you're keeping up with the course. Academic integrity. Those of you who have taken courses with me before know that I'm reasonably diligent and, well, you may or may not know. Hopefully you don't know, but if you do know, you'd be aware that I'm reasonably strict and reasonably diligent in terms of academic integrity. I am checking all of your work. and running it through a variety of different checks and checking it against work that was previously submitted to the course and work that might be found on the internet. So as a general rule, hopefully by now, all of you should be aware of what the academic integrity policy is. If not, take a look at it. That's the link right there. But in summary, don't copy other people's work. Don't submit work that you haven't entirely done yourself. Don't do anything that gives you an unfair advantage over other students. So pretty much anything where you're getting access to something or an advantage in some way that other students won't necessarily have, that's probably bad academic practice at the very least, and probably a breach of academic integrity policy. Now, I know that this has been a point of confusion for a lot of people from the past. Each of your assessments will have a summary of the key academic integrity requirements for that assessment on that assessment, and you'll find them fairly clearly written right at the top of the assessment. So hopefully that addresses any questions about what is and isn't allowed for each particular assessment. But at the same time, yeah, sure. Hang on. Okay, how about that now? That should be a bit better. Someone's saying that the sound was a bit quiet. So hopefully that's a bit better in terms of sound. So yes, hopefully it should be a little bit clearer for each individual assessment what the specific requirements are, but at the same time, because it's very clear for each assessment, there won't be any excuses in terms of, oh, I didn't know that that wasn't allowed. It should all be quite clear in that regard. But if you're unsure, or if you are thinking of doing something and you're not sure if it's acceptable or not, you can always, at the very least, ask. And I would rather that you ask than find yourself in a position, a few weeks later where you're hauled up in front of an academic integrity board, because it's not a fun time for anyone involved. It used to be the case that I would be there for all academic integrity reviews. I am not there anymore. Your course coordinator does not show up for those reviews, or we're not allowed to be there for those reviews. So you have a panel of people from the faculty and an academic integrity officer from the school sitting down for a very, very uncomfortable meeting if you find yourself in breach of the academic integrity policy. So if you're unsure, please just ask. Hopefully we don't run into any issues with that this semester, but be aware I will be looking. A lot of the time people run into issues with the academic integrity policy because they get stressed because it's close to a deadline. Please manage your time as much as possible, but if you need an extension on anything, please just contact me. There is no harm in asking. The very worst that I can do is say, no, I can't give you an extension for that. So just ask as soon as possible. If you even think for the very slightest moment that you might need an extension, please just ask. I'd rather that you ask me and then not need the extension after all than miss a deadline and then ask me afterwards, because after the deadline, if you contact me for an extension after the deadline, you're not going to get an extension, at least for full marks. I might be able to offer you some kind of arrangement, but generally not for full marks once it's after the deadline. Speaking of after the deadline, what is our late policy? So you should be aiming to hand everything in on time, but our school generally goes with a policy of capping your mark or setting the maximum mark within each 1 day late. So as soon as typically the deadline will be 11:59, well, midnight on the day that an assessment is due, or like 11:59 p.m. on the day the assessment is due. And once you go past that deadline, within the first 24 hours or the first one day that it's late, submitting after the deadline within the first day, your maximum mark, because the maximum mark that you can get will be 75%. But we're not going to scale your mark down by 75%. Your mark's maximum can be 75%. So if you were submitting an assignment that was only worth 50 out of 100, if you submitted that one day late, you'd still get 50 out of 100 for that assignment. If you submitted 2 days, actually, I'm going to say 60. Let's go with 60. So if it was worth 60 out of 100 and you submitted one day late, you'd still get 60 out of 100. If you submitted within 2 days late, so up to 48 hours late, then the maximum mark you can get is 50. So you would get 50 in that case. And if you submitted up to 3 days late, then you would be capped at 25. Maximum mark you can get is 25%. Marks below 50% not affected. That should read 25%. Hopefully, very clearly, that should read 25%. I'll get that corrected for everyone. But if it's more than 3 days late, your mark's going to be 0. And that's that. And I think for the most part, this is the standard policy across the school. There are some assessments where late submissions are just straight up not accepted. And in this course, that's going to be the exam. You can't submit late in the exam. But aside from that, this policy will apply to all of the programming assignments. In general, you can submit multiple times to assignments for the most part. And if you do submit multiple times to an assignment, then we'll make sure that you get the higher mark with some conditions. The marking system that we're using, or the submission system that we're using this semester, does not do this automatically. So you will get to choose which submission it is that your mark is taken from. And that's the one that we will use. For the most part, our programming assignments this semester are going to be a combination of automatic and manual marking. So as long as you make sure that the submission that you want to be graded on is the one that you have selected in the submission system, then that should be fine. As briefly alluded to earlier, if your final result is in the 45 to 49 range, then you get an additional assessment or a sup exam. In general, it's always going to be a sup exam, although I understand that in some cases, it may be that having a sup exam isn't going to help you. So if you have completed all the required coursework, we may be able to offer a sup assignment instead of a sup exam, but for the most part, it's going to be a sup exam. And that's going to replace the score of the main exam, and hopefully that'll bring you up out of the 45 range. In this case, because you haven't actually managed to pass the course in the first instance, your mark is capped at a 50 if you do manage to pass with the sup assessment. You will need to make yourself available during the additional assessment period for this. The sup exam will be set on a particular day and time, and if you are not there for that, that's just too bad. So you need to make sure that you are available for that assessment if you end up in that situation. A few additional bits and pieces of information about sup assessments. So sup exams or replacement exams, we're not going to give you a replacement exam for minor ailments or a bunch of other things. It's generally only going to be if you are seriously ill or have a serious issue in the exam itself, and the policy goes through details on what's okay there, what isn't. I understand that a number of you may be affected by COVID throughout the semester, and there are still special arrangements in place for that. Yeah, that's that. Don't sit the main exam if you're given a replacement exam, so a replacement exam as opposed, here I am mixing things up. Okay, so a replacement exam is different from a sup exam. A replacement exam is where you apply to basically not sit the main exam, and because you're unable to sit the main exam for whatever reason. If you are given a replacement exam, don't sit the main exam. And if you sit the exam, you won't be eligible to apply for a replacement exam unless a major issue arose during the exam. Again, like with sup exams, you need to make sure you're available during the replacement exam period. And if you have already sat a replacement exam, you won't be eligible for a sup exam. There's a few bits and pieces around that, and we'll discuss that situation if we run into it. But for the most part, the replacement and the sup exam are two separate things, and you can't have both, with some exceptions in some weird circumstances. There's also an option for a deferred replacement exam if you're unable to sit the primary exam or the replacement exam under very specific circumstances. Generally, for the most part, a lot of that stuff gets handled by the exams office, but we'll provide more details throughout the semester here. Okay, so moving on to key bits and pieces about this course specifically. How do we get the most out of this course? You're all honors and master's students. I think that's the first thing that I want to make a note of. And I'm aware that maybe there's a couple students in this course who are still undertaking this course as it is listed as a third-year course for you. However, the study plans and the programs have changed. This course has now been a honors master's course. This is the third year that it's been an honors master's course. So I think we're all honors and master's students here. So that means that I have different expectations from you than I would have of undergraduate students. You're going to need to keep up with the course content. As an honors master's course, it is not the role of this course to deliver you all of the content per se. It's my job here as the course coordinator of this course to make sure that you are provided with some of the key resources that you need, and that the assessments that you are given and the resources that you are given are there to help facilitate your learning, but you will need to be active learners here. And that means that you might need to go out and do some research and review some research papers and a variety of other resources on your own. That is entirely separate from the actual content that we provide, and we're not going to provide that much explicit content to you. It's very much a self-directed course in that regard. So yes, you're going to need to be active learners, and that means just reading the notes themselves and the textbooks themselves. That doesn't necessarily mean that you can do it. So actually practice doing the solutions, because it's very easy to say, yes, okay, I read that, that makes sense, moving on. Actually try and practice the various different bits and pieces. There are a few skills that you will need to pick up as part of this course to make sure that you are properly able to succeed. And hopefully the exercises that we have in workshops and the programming assignments will help equip you there, but you will still need to practice the various concepts. Come to these sessions prepared. We talked about that earlier. If you are just showing up to these sessions, you probably still get some stuff out of them if you are just showing up, even if you haven't prepared. But the expectation is that you have read the readings, reviewed the various bits and pieces of information that you'll need to beforehand, and maybe tried a couple of exercises before coming to this session. And hopefully you have some questions ready to ask, and then we'll all get the most out of these sessions here. Do the programming assignments or do the practical assignments. that's going to force you to apply the theory, but it's going to be they're going to be quite high level. So we'll be looking at a bunch of different concepts throughout the semester, and then you'll need to actually go through and apply them in depth. They're not going to be necessarily straightforward assignments. They're probably going to require you to dive quite deep into various areas, and you may need to do additional research around the rest of the course content in order to be able to actually undertake the assignments. And come to workshops if you can. I highly recommend coming to workshops if you can. They're a really good place to ask questions, get feedback, and work through examples. Yeah. Does anyone have any questions that they'd like to ask about any of that before we move on? Oh, we have a question, yes. Feel free to unmute yourself or ask in the chat.
Okay, I'd like to ask one thing.
Sure.
In the course material section, we had like 3 to 4 books and one journal from IEEE. So those are about JavaScript, right? As far as I checked. So first of all, do we need to learn JavaScript for this course? And any other extra like PDFs or books we need to go through?
Yeah, so there'll be a couple additional books to the ones that you see on the lists that are already there. And for the most part, all of the materials that I make available to you should be just free, or at least free through the course readings section. Some of them may not be, but I'll try to stick to ones that are fairly inexpensive. So there may be a couple books that pop up over the course of the next few weeks that are $20 to $30 each. I'm currently in the process of vetting those and talking with the library staff who deal with the course readings and the course readings tool about just making sure that they are proper suitable, because if they are not going to be free for you all, then I want to really make sure that those are absolutely 100% what we're going to be using. In terms of JavaScript, it's a good language. In terms of event-driven stuff, we won't necessarily be using strictly JavaScript throughout this course, and it is my general expectation that everyone in this course has a reasonable programming proficiency across the board, such that if I ask you to pick up a programming language that you haven't dealt with before as part of this course, that should not be an unreasonable ask at this level. So it won't necessarily be JavaScript, but that particular reference material is relevant beyond just specifically the JavaScript itself. And if I'm asking you to use other programming languages, I'll generally try to provide some guides for those specific languages. So I do not have a 100% concrete answer right now. I will try to, if possible, open up programming assignments to be able to receive multiple programming languages. I know that's probably not as clear as you wanted at this point.
Okay, so for week one, can you please suggest us a guideline? I mean, what we should go through, right?
Yeah. So to start off with, you want to be looking at the course notes on finite state machines, and there are also some corresponding chapters, I think, in Horstman. No, not Horstman. Finite state automata, the pink book. Which do I have that? No, I do not have that one with me. There are some corresponding chapters in there as well. Basically, prepare for week 2 is the aim there. So in terms of all the before lecture stuff that's listed in week 2, you want to be doing that throughout this week, if that makes sense. If that's less confusing for everyone, I can move that stuff potentially into the week 1 resources. But for this week, just make sure you're clear on everything for week 2, ready for week 2.
Understood. Thank you.
Cool. I was still muted. Okay. Before we go any further, does anyone else have any other questions that they'd like to ask? Okay. All right. Okay. So we've alluded to this a little bit already, but what is event-driven computing? What are event-driven systems? Hang on. We'll come back to that. What are event-driven systems? What do people think? Feel free to post your thoughts in chats or in the chat. What are event-driven systems? What makes a system event-driven? That's okay. You came to this lecture looking for probably the answer to that question, or possibly the answer to that question. What is an event-driven system? What makes a system event-driven? Let's take a look. Now for okay. Yes, pretty much. Okay, so well, for the most part, the programs that you've been writing thus far in your degrees, you may have come across some event-driven programming at some point, but a lot of the programs that you've written so far are interactive. And that is to say that you run it. Well, some of them are just straight up procedural in that you run the program does something, it spits out an output, and like that's it. For a lot of the programs that you may have written are interactive. That is to say that you run the program does some stuff, and then the program's all like, hey, I need some kind of input from the user. It prods us to give it data, and we wait there for it to go through and do its thing, and then give us a confirmation or ask us for some more data, and then we give it that data, and it continues on, and this cycle goes on and on until the program finishes in some capacity. Maybe it spits out a file, or maybe it just ends, and like that's it. And that's interactive computing, and that's what we've been doing for the most part up until now. Now, event-driven computing, which sometimes you'll hear referred to as reactive computing, but this will vary depending on the context. So event-driven computing, it's about reacting to data as soon as it arrives. You'll have some kind of action or event that occurs, and the system will need to respond to that. Different to interactive computing, the events or inputs can happen at any time. The system is driven or runs based on these events occurring. And in some cases, we have programs that are asynchronous or concurrent. That is, the program is doing stuff in the background, and then an event occurs, and that's going to actually interrupt the stuff that's going on in the background. The program's going to do stuff based on the event that has just occurred, and then it might go back to doing the other stuff that it was doing in the background. For event-driven systems that are user-based, for example, graphic user interfaces, the user should always be in control of the system. So the system will be running and doing stuff in the background, but as soon as the user interacts with the system in any way, that's probably going to trigger an event of some sort, and that should cause the system to react to the event that has occurred accordingly. what are some examples of some types of event-driven system? We've already said graphical user interfaces. What other examples can people think of systems where the software is responding to things that occur rather than just going along and then waiting for the user to provide some sort of input? A calculator? Yeah, that could be a potential example of an event-driven system. What types of systems do we think of? A calculator could be an example of a very simple embedded event-driven system. Yeah. Come on, people. There's 20 of you here. Games? Yep. Yeah, anything. Yeah, games are a good example. That they are very heavily event-based, and I think many of you would be aware of potential issues with input times and input latency in games, and potentially the differences between polling and event-driven systems. CVBS architecture. CVBS. I'm not familiar with that acronym. Would you be able to expand that acronym? Converging billing system. Ooh, potentially. Yeah, I'm not super familiar with that, so I'm not entirely sure. But potentially. If you have like a centralized billing system that receives inputs from a variety of different sources simultaneously, then yeah, that could absolutely be an example of an event-driven, a type of event-driven system. Operating systems, I assume that was what was being typed there. Operating systems, yeah, typically, yeah, they're absolutely, they're heavily event-driven because the computer itself is event-driven and includes a variety of mechanisms for reacting to things that the user does. So in a lot of cases, an operating system, or at least an operating system with a graphical user interface, is going to be event-driven. Okay, yeah, let's take a look at some examples. So yeah, we've already talked about graphical user interfaces. Pretty much anything with a graphical user interface has some sort of event-driven component to it at the very least. Embedded systems, so for example, a basic calculator, yeah, that's an example of an embedded system, and those will be heavily event-driven. Pretty much anything that involves networking is going to be event-driven because we have to react to data coming over the network, which can occur at any time and can be spotty. And anything involving communication between multiple different processes, many of those can be event-driven depending on the system. So those are some examples of different types of event-driven systems. Those are all fairly broad. And if you start thinking about the systems that you interact with on a daily basis, you'll probably find that most of them fall into one of those four categories. And probably most of them fall into the category of a system with a graphical user interface. Some of them might fall into several different categories there. So you may have done some graphical user interface programming throughout your degrees thus far. But a lot of the programming that you might have done as well might have been completely different. So we're going to focus on the different things that we should be watching out for as part of dealing with event-driven systems. What challenges do event-driven systems create for us as programmers? What are we thinking? Can we think of any challenges that an event-driven system potentially creates for us as programmers? Missing data? Yeah, potentially. or at the very least, data arriving out of order. Yeah. Simultaneous or spammed inputs, absolutely. 100%. Error handling, absolutely. Yes. Yeah. All right. Let's take a look. Okay. So unpredictability, and I think this sort of falls into the missing data and maintaining state. Well, maintaining state and missing data falls into unpredictability and maintaining state. So the first thing that we need to consider is that any event can theoretically occur at any time in an event-driven system, or at least in the fundamental idea of what makes an event-driven system. The idea is that events are what drive the system. So all of the available events that can occur, in theory, any event can occur at any time. We need to make sure that we account for this when we're writing our programs. Otherwise, if we don't account for this, we enter the realm of undefined behavior. We enter the realm of undefined behavior if we don't account for this. And when we enter the realm of undefined behavior, it's like, oh, who knows what the program is going to do? Things get weird. We want to very explicitly avoid undefined behavior, especially in event-driven systems. Responsiveness. In general, users, especially user-facing event-driven systems, we expect those systems to respond immediately, or at least in a timely manner, to an input. So I'm sure if you've been playing like a game on an older computer or something like that, or even just over a poor network connection, it can be quite frustrating when your inputs, there's a noticeable delay between your inputs and then the action actually happening in the system itself. So we want to try to design our systems so that they are specifically going to be responsive. Maintaining state, and this is especially applicable in the state-based view that we're going to be looking at over the first sort of half of the semester. So our system will be in a particular state and then an event occurs of some sort. How do we make sure that we remain consistent? So whether that means moving the system to a different state, changing the state as a result of the event, or the event occurs, we take some action, and then we return to the previous state. How do we maintain that properly? How do we ensure that the system continues and runs in an expected manner? And of course, concurrency. So events, the program can potentially be doing other things in the background, and events can potentially interrupt that and cause the other things in the background to have to stop mid-execution. So what do we need to be aware of in a system where events can occur at any time, events can interrupt the regular flow of the program, and how do we deal with multiple events happening simultaneously? If an event occurs and we receive that event and we start dealing with that event, and then another event occurs, what happens? Is it going to like cause the first event that we're working on right now to break? Are they both going to run simultaneously and mess with the same piece of data at the same time? How do we handle that? And we'll be talking about that in the context of a few different systems, because depending on the system and the architecture and the programming language will depend on how events are being handled, how we deal with concurrency. Some programming languages are explicitly designed to just not worry about concurrency issues and maintain consistency across the board at the expense of performance, whereas other programming languages allow us to actually do run multiple events simultaneously and then potentially modify the same piece of data simultaneously. And things can get weird if we're not careful. So these are all the things that we want to take into consideration when we are looking at an event-driven system. Okay, how do we address these challenges? Does anyone have any ideas on how we can deal with some of those challenges? Okay, all right. So suggestions. Um, interrupts? Question mark. Good question mark. Well, interrupts are generally going to be the thing that actually causes these challenges in the first place. We can't necessarily have simultaneous events occurring without some sort of interrupt based system. So that potentially introduces the problems. It doesn't necessarily address them, but I like that you're thinking about interrupts. Multi-threading, if we have to deal with concurrency issues, um, potentially, but I would argue that multi-threading in and of itself is not necessarily the solution to concurrency issues. But again, I like that we're thinking about that. Ignoring inputs that would cause undefined behavior. Yeah, that I mean that's probably one of the most one of the simplest ways to deal with things. That said, um, it depends on what we do when we ignore the inputs. I would argue that it is better to explicitly ignore the inputs rather than implicitly ignore the inputs, and that's what we mean when we're talking about undefined behavior, which I think pretty much is what you were saying. So that's all good. Better to ask the stakeholder to provide the missing data. Potentially depends on what you mean by stakeholders. If we're talking about a promise-based architecture, that's a little bit different and outside the scope of what we're aiming for in this course, but a promise-based architecture is a good way to address a basic event-driven system. But I believe that concept is looked at more in parallel and distributed computing or distributed systems, one of the two. We're not going to be going on to promise-based architecture in this course, but that is a good way to avoid the issue altogether, which is good. So in terms of what this course is going to focus on, we want to address all of these challenges through robust design, effectively. That's what we want to focus on in this course. So make sure that we model out the problem appropriately and that the architecture of the software that we use to address or to build up the system is explicitly designed to handle these sorts of challenges. It's very tempting to just see a bunch of inputs and throw a bunch of code at it without necessarily giving that code any structure. And that's where the errors start creeping in. So for the first few weeks, we're going to focus on some explicit different models that we can apply to how we design our program, how we model the problem that the program is trying to solve, and how we can then code that out to explicitly avoid running into issues. It does make the programs more complex than they might otherwise need to be, but at the same time, it makes them very robust, and robustness is really important in an event-driven system. Deterministic management of state. So that means that we want to make sure that we always understand the state that the system is in, and that the system is not simultaneously in multiple states. At least to start with. Depends on the model a little bit, and we can model things in a more complex way that makes it slightly less deterministic, but we potentially run into errors when we build non-deterministic systems. So ideally, we want to drill everything down to a deterministic system. And finally, on top of all of that, or if it's not possible to make our system deterministic, for example, or not easily, we want to make sure that we have robust error handling mechanisms on top of all of that. Okay. I want to try a bit of an exercise. We'll take 5-ish minutes to have a go at this, but we're just going to start by looking at the fundamentals of a state-based system. So the scenario is we have a light and a button. And if you press the button, the light changes from what it currently is doing to the opposite of what it currently is doing. So if the light is off and you press the button, the light turns on. If the light is on and you press the button, the light turns off. how might we model this? A lot of the stuff that we're going to be looking at right at the start here is going to be focused on modeling and drawing out models and diagrams for understanding our system as a whole. So let's try to think about how might we draw out what was just described there. No wrong answers. What I'll get people to do is hop onto Piazza, and I've just opened up a live Q&A, and go ahead and have a crack for the next 3-ish minutes of seeing if you can draw out a model of some sort for the system that we've just described, and then post your model in the live Q&A. And we post in the live Q&A just by going into Piazza, creating a new post, and when it says post to, make sure you have live Q&A session selected. You can put images and stuff into your questions and or text, whatever you need to, and we'll take a look at some of the options that come up, or some of the things that people come up with. So 5 minutes, let's have a go, and I'll be right back. So again, no wrong answers here. Try to think how we can represent each of the key things that we want to represent in this type of system. So how do we represent the states within the system? How do we represent the different events that cause us to move from state to state? And what are the states and what are the events in the system? Yeah, that's it. You'll probably need to select a category as well. Which category should we use? Let's go ahead and feel free to use the DFAs or other category, doesn't really matter. All right. So for those of you working on this one at the moment, and hopefully more than just one of you is working on this, unresolved follow-up. Okay, fair enough. But if you have been working on an answer for this, if you go ahead and submit that now. All right, so while people are submitting that, let's go ahead and stop sharing our screen for a moment there. So hopefully everybody can see my camera over here. All right, so yeah, how are we going to model this? So I think the first key thing to note is the word model here. We're not looking so much for a high-level overview of the system as we are for a diagram or something of some sort to understand the basic mechanics of the system that we are trying to build, and that we want to have something that we can effectively translate directly into software. So we want to represent the states of the system and the events that cause the state transition, or the movement from state to state. Now, what would we say is the states of the system in this instance? Got a few more answers coming in. All right, so we've had a note about an event loop pop in. So I think the first thing to be aware of is that an event loop is at this stage, we're looking at a really low level overview of this type of system. Now, an event loop is a construct that we have to deal with in a programming language. And we will be talking a little bit about event loops later on in the semester because it helps us to understand how the programming language itself deals with the idea of events coming in and how it manages the difference between events and the rest of the main piece of code that runs. But for a system like this, we just want an overall model of what we expect the behavior to be of the system itself. So an event loop is probably a little bit out of context, but I like that you are thinking about event loops because it's something that we'll have to deal with. Okay. Oh, look at that. Okay, that's nice. And we got some code and stuff as well. All right. Yeah. What do we think the basic state of the system that we're dealing with is? Have I just been talking this whole time not into a microphone? I am unmuted. Yes, I am unmuted. Good. I know I'm asking you to think at 10 o'clock in the morning on a Monday. It's rough. Okay, yeah. Okay, so yeah, no, that's a good point. Okay, so we're not sure. That's okay, and I don't expect us to just like know this off of the bat. So in the system that we've described, so when we're talking about state, waiting for an input, I suppose we could consider that a state, but in the example of a system where we have a light and a button, and we press the button, the light goes on or off depending on what the system was doing before. Waiting for an input is probably overcomplicating things from what we are looking for. Listening to an action and trigger if a specific action is taken. Well, that's what the system needs to do. But in terms of the system itself, as in where we have a light and a button and the light is either on and off and the button can be pressed, what are the basic states in that system specifically? Light and button. Yep. Okay. This is good. We're starting to think in the context of the system that we're trying to develop for. Again, like we're going for like a really simplistic view of the specific problem that we're aiming for here. So yes, that looks good. So I think the key will actually draw this thing out now. Let's take a look. So we've had a few different examples posted. I'm seeing some nice flowcharts pop up, which is good. Yeah, okay, I'm seeing some flowcharts. So I guess the first thing that we have is what are the different states in the system? So we're aiming for a state-based approach to the problem. So that means we're going to have two different states in the system. We're going to have the light is off. And the light is on. And these are our two states. Now, these can be squares or diamonds or whatever shape you like. We're going to use circles just to start with. But we have light is off, light is on. those are the two states that those are the two states that the system can be in, yeah? Because either the light is off or the light is on, but like those are our options, yeah? I'm just going to take that as people are roughly understanding this. Okay, so now when the light is off, what causes us to move from being in the off state to the on state? Yep, exactly. And draw a little arrow here. And this represents our event here. So the event is an arrow that moves us from one state to another state in a really basic state-based system. And similarly, we go back the other way. And that's our basic system, right? So we have two states. The light can either be off or the light can be on. And when we press a button, we move from one state to the other in our system. Now, potentially, as part of the button being pressed action, we can then actually turn the light on or turn the light off. And there's a few different approaches that we can take to that, and we'll look at those as we go in terms of the actual how do we code a system like this. We'll look at those different approaches over the next few weeks. So don't worry, we are going to look at all of that. I've seen some people posting some code in terms of the flowcharts that were posted. So we've seen a few flowcharts that were posted that look something like this. Input So we saw some flowcharts that look like that. So we have an input, which is the button being pressed, and then it's like, is it on or off? And if it's on, then we would go to off, and if it's off, we would go to on. Some people drew diagrams which look like this, which is objectively correct, right? This is what we're going to do for very specifically. We receive this input, we check to see is the light on or off, and then we action it based on that. But when you have hundreds of different, and this is what we're going to effectively end up with in our code, but we'll have to do that for every input and every single possible state within the system. So we have to, so this is eventually what we're going to end up with in terms of our coding, but in terms of modeling the system, what we want to start out with is a basic model like this so that we have an overview of all of the possible states in the system and all of the possible ways, all of the possible events that can move us from one state to another state. Finally, we probably have to have the system get initialized in some capacity. So we're going to add a little lightning bolt arrow here to the initial state. Whichever one we add a lightning bolt arrow to, that's where the system starts. So presumably the system is going to start with the light off, but one could potentially make an argument for doing it the other way around. I think there's a few different ways that we could consider this, but this is the basic model of what we call a finite state machine. And this is the basic model that we're going to be starting with and looking at in terms of how do we build a resilient event-based system. We're going to be looking at that for the next few weeks and different variations on that and more complex models and how we approach those more complex ways to model the system. Before we move on to more modern architectures, reactive programming, event streams, data streams, and event handling, all those sorts of things. So yeah, but this is our basic event-based system. So hopefully that's given us a bit of an insight into what we're starting to look at, given us starting to get our heads into the space of looking at and modeling basic state machines for handling event-based systems. So does anyone have any questions about that? All right, so that's our basic state machine. As I mentioned before, we're going to be moving on to some more modern approaches as we progress through the system, but we'll start with these fundamentals and we'll go from there. So what's happening in this course? As we talked about this a little bit earlier, but this week, what I want you to do is take a look at the notes on finite state machines. You'll find them in the course readings. Read through chapters 0 through 2. If you have any questions, bring those along to next lecture. We're going to be recapping some key concepts of that, and we're going to be answering questions and discussing the fundamentals as covered in chapters 0 through 2 of Notes on Finite State Machines. In addition, your first programming exercise will come out, or programming assignment will come out next week. And that one will be due at the end of week 6. And that's going to cover a good chunk of the content all the way from now all the way through to probably about the end of week 4-ish, depending. Yeah, that's that. Does anyone have any other questions or anything they'd like to ask for today? Can't share right now. We have a few limitations. We're using a new grading system this semester. And the question was, can we ask for a hint on how to prepare for assignment 1 in terms of implementation language? Ideally, these assignments are going to be language agnostic, allow you to submit in a variety of different programming languages, but there are some limitations that the grading system, when we're using a new grading system this semester, places on those sorts of assignments. And we're still waiting for some confirmation on a few of those. So I can't give you a concrete answer on that just yet, but I will let you know in detail as soon as I do. All good. Thank you for asking. Does anyone else have any other questions they'd like to ask at the moment? Going back to the model. Okay. In an event-driven system, the events are modeled as transitions between the states. Yeah, in a state-based event-driven system, yes, the events are modeled as transitions between. The events are modeled as the thing that causes us to move from one state to another state. In terms of how we model the action, so the question was, does this mean, going back to the previous thing, that the events are modeled as the transitions between states? Yes. In terms of how we model the actual actions that we take as a result of these transitions, we'll look at that a little bit later on. But yeah, that's the basics. We have the states of the systems, and the events cause us to move from one state to another in the most basic state-based event system. Yeah. Good question. Follow-up. Oh, this is a good follow-up question. So the question is, that means that when designing an event-driven system, the designer must predict all possible events. Is that right? Otherwise, we could have some implicit state changes that are not core. Yes, we need to account for all possible events. And there are ways to indicate that in the diagram, which you'll see when you start going through the first few chapters. But yeah, the all possible events, that's what we call the alphabet of the system. It's the all the possible inputs that could be received, and we want to design our system in such a way that it ideally it explicitly handles every possible event, but there are ways that we can address ranges and series of events in the system, or at least explicitly provide a default behavior for everything else. Yeah. Yeah, I agree. So implicit state changes that are not caught, that is something that we very explicitly want to avoid. And that is something we are trying to, by modeling a system out like this, we are trying to explicitly account for. And that's what we're aiming for with this first few weeks. Yeah. All right. Thank you all very much. Oh, wait, no, hang on. Okay, in terms of all possible events, are there any priority? Which ones we list first and which ones will get least prioritized? For the basic systems that we're starting with, no, there are no such thing as priorities. Ideally, an event occurs and that results in a corresponding change from one state to another. And that change may trigger some behavior, but all events should be responded to ideally, effectively, immediately, and with equal priority. Yeah. Okay. Okay, thanks a lot, everyone. That's it for today. So take a look at the first few chapters of notes on finite state machines or finite state automata, and we'll see you all next week.